I'm going to go ahead and get started. So what is functional programming, right? So I know some people in the chat were saying, hey, functional programming, I don't know anything about it, but it sounds familiar, right? Functions and programming. And you've got the right idea. Functional programming is a style of programming that emphasizes functions. So hopefully, how many of you know what a function is? I know there are some people who are like complete beginners. How many people have written a function before and know what a function is? Somewhat, okay. I think I have. Yes, okay, functions. So don't worry. Well, I'm actually going to get into that as well. So if you're like, hey, I've never heard of a function. If you've never programmed before, you might be a little confused in this talk. But even if you don't know what a function is, you should be fine. This talk is in JavaScript. So if you were in the Intro to JavaScript talk, workshop earlier this morning, that will definitely be helpful, or if you know JavaScript. But if you don't know JavaScript, that's okay. The syntax is pretty easy to pick up. If you know anything, C, Java, even Python, you should be able to piece it together. So you have all those languages. There's also, you may have heard of functional programming languages. So there are actual languages that are specifically dedicated to functional programming. And they have features that are built specifically for functional programming. But a lot of them, they aren't necessarily as prevalent as typical languages. And you don't necessarily need to use a functional language to do functional programming. Again, it's a style. So it can be easier in a functional programming language to use the functional style, but it's a style, so you can ultimately use it in any language with enough effort. Okay, and so why should you care? Like functional programming, okay, programming with functions, great. But why does this matter to you? Well, I think you should consider using functional programming because most major languages, especially recently, there's been a big push towards having functional features in every programming language. So even something like Java. Java is historically a very object-oriented programming language. It was designed to be object-oriented. That's like its big selling point. But even Java has recently incorporated features that are from functional programming. And that's because these features, I think it's just because these features are so good. They're such powerful, useful tools that even a language that isn't necessarily functional, they're incorporating these features because they're just that great. Yes, Java Spring Boot is a great example of, functional programming being a huge thing. JavaScript at its heart, like in a lot of cases, is a functional programming language. Another thing is a lot of the main ideas that you see in functional programming, especially the beginning things, are just good practice. Like they're things you should be doing anyway if you're writing good code. So that's another reason why I think functional programming is good. So I'm going to actually kick things off with a demo so you can kind of get an idea of why you would want to do functional programming. So let me go ahead and pull that up. Okay. Can you see this terminal? You should be able to see a terminal with talk functional workshop. You see that? Okay, awesome. So I'm going to go ahead and head into my demo folder, and I have a demo file here. I'm going to ask you some questions, and as the audience, see if you can try to guess the answers. So here, if you're not, functional programming is scary. No, functional programming is not scary. It shouldn't be scary, okay? In this talk, it's a lot of times you hear it thrown around, and one of the main problems is that there's not necessarily a single definition of functional programming. Everyone has their own kind of idea of what it is. It's not such a specific thing, which is one reason I think people can get scared by it, is there's not really a lot of people disagree on exactly what it is, but I'm going to kind of give you some ideas that are like, everyone kind of agrees this is sort of functional programming. So if you look at this, this is some JavaScript code. If you're familiar with JavaScript, hopefully we have some people who are fairly experienced with it here. This first line you can see here, this is an import. So if you've used Node.js, if you haven't, don't worry about it, but this is an import. If you've used C, this is a lot like your include. This does a very similar thing. So we're going to import some things, get data in my object. Don't even worry too much about that. We assign this message. Is this safe? And we're going to print this out. Then we'll have some commented code. We're going to uncomment that in a minute, and I'm going to ask you some questions. And then down here, we're going to print it out again. So if we run this, you will see we get, is this safe printed out twice. My question for you, if we uncomment this line, I don't know if we have any JavaScript experts out there in the audience, but does anyone have a guess on if we uncomment this line, will this change the output? Any guesses? Don't worry. I'm not gonna call you out. Okay, no. So you might think by default there's no way of knowing. Okay, so Jim, why would you say there's no way of knowing? We don't know what get data. That's true. Okay, it could print something and throw. Okay, I'll tell you this. It doesn't throw an exception, and it doesn't print anything out. Yeah. So this, I just uncommented this line. What I'm wondering is there any chance this could possibly corrupt this console.log down here? Okay, so we have some people who have different ideas. Nicholas guessed no. Jim says suspects that it's possible if the data is a virus. Maybe it's not a virus. Probably not. You would probably expect that it should still do the same thing. But in fact, if we run this, is it safe? No. It could also reassign console.log. So in this case, the issue we're actually having here is that in JavaScript, a lot of people who are new to JavaScript, and especially who've written Python, assign their variables like this. They just do the variable name and equals. But it's actually a common misconception. This is a really bad idea in JavaScript because when you do this, you create a global variable that can be edited from anywhere. So you should always, always, always use a const, or your other option is let. In legacy code, you'll often see a var as well. But these days, you should stick to const and let. So if we do a const, that will make it so that this can't be edited. But as Jim has pointed out here, even if we do that, it's still possible. So is this safe? It's better, but it's still not completely safe. And a lot of people get really mystified by this. But you actually kind of spoiled my my demo in that it can reassign console log, which is something else that you can do in JavaScript. So this function, inside this get data, console log is being reassigned. Okay. So let's go ahead and get rid of that. What if we instead run this? Is this safe? So we import this object, my object, and we're just going to pull out one of its sub-properties. Do people think this is, are we going to get the same message back, or is it possible that somehow we could get different messages? Any guesses? Okay, no one willing to guess. If it's a const, probably. So again, you would think probably the same message, but even accessing the property of an object isn't necessarily a safe operation in JavaScript. And the reason this can happen, so I'll go ahead and show you what's inside of the library I have here, is you can, and Jim already figured this out before I said it, you can reassign console.log. And for the object, when you access a property, it actually can be calling a function if it's a getter. So JavaScript has this thing called a get syntax. And don't worry if this doesn't make any sense to you. This is just kind of to give an example of why it can be dangerous to have so many things changing. Even accessing the property of an object could potentially override console.log or any other function that you write. Because that's just something that JavaScript allows. The code is a lie. Yes, exactly. Portal references. So we don't want our code to be a lie. That's a pretty bad thing. Don't trust anything. And that is kind of a core concept in functional programming. You shouldn't have to trust that other functions are going to do the right thing, because they could change things behind your back. So the real question I want to ask here is why is the code in my library so evil? And the answer is state, in short. State is basically anything in your program that can change. So all your variables, in this case, console.log was a kind of state because it can actually change. And by default, in most popular programming languages, especially JavaScript, Python, Java, most of the big ones, anything can change at any time, right? All your variables, they're called variables for a reason. They could change. And if you call a function, it's possible that your variables could change. If you access a property, it could call a function that changes your variables. And even though most likely if you're working on a project, you're not going to have some evil person like me who's overriding your console.log function. That's not going to happen. But what you might have is different people changing global variables or doing similar things like that, appending things to arrays or whatever, changing the global state. And anytime you change things, it quickly becomes complex. And eventually, once you reach a certain point, it's going to become so hard to maintain this code because all these things are changing that it's impossible to be certain exactly what the system looks like. Okay, and so why is this true? So actually, I did some research. Psychological studies have shown you can only keep 5 to 9 things in your short-term memory at a time. That's it. So if you're dealing with any code where you have more variables than that, if you're ever in a situation where you have 10, 11, 12 variables, functions, objects that you're trying to use them all at the same time, you can't keep track of it. You're not going to be able to manage all of that state, all those things changing successfully. And what does that mean? You're going to have bugs in your code. So functional programming is kind of a way to push back against that. One of the first primary concepts in functional programming is outlawing state. So once we initialize a variable, we never change it again. And this is called immutability. Immutability just means, so if something can be mutated, we often say when we change something, that's like a mutation, right? We mutate it. So if something's immutable or has immutability, then it can't change ever. So in JavaScript, that means we should use const. So if you use const, const stands for constant, and in general, it is able to keep things the same. There actually are some exceptions to that. So const doesn't actually make things completely immutable. I wish there was a keyword in JavaScript that did do this because it's something I would use all the time. Unfortunately, const is the best we have. What const actually does is you can't reassign something, but its properties can still change. So if you have an array, right, in order to add another item to an array, you use the .push method. So this is a function call on. If you haven't done object-oriented programming, don't worry too much about it. But we can make this const weather states and start it with just sunny and rainy. And then if you do push is like append or puts it to the end. We can add overcast. And then if we console.log, that's print in JavaScript, we print it back out, we'll get sunny, rainy, overcast. And that's sad because we don't want to be able to do this, right? So there's no way we can actually keep things completely immutable in JavaScript. What it does stop you from doing is it won't let you do this. So if you try to take weather states and assign it to a completely new array, const will prevent you from doing that, which is a good thing. But you are still able to edit the array you have. So you can swap out things, you can append, you could remove elements, but you can't actually change it to be a different array. So basically, whenever you're using JavaScript, I'm a big advocate of constantly const. If you can use const, you should. Anytime, try to avoid, you should never use var and only use it if you absolutely have to. Prefer const whenever you can. Okay, so kind of back, basically the summary here is that const will prevent you from reassigning, but you can still mutate the object or the array. So in order to kind of maintain our immutability when we do functional programming in JavaScript, it's purely just discipline. You just have to make sure that in all the code you write, you never edit your arrays or your objects after you declare them. Even though you technically can, just make sure you don't do it. And then you're adhering to functional programming paradigms. So immutable data has a lot of benefits, right? When we call functions, nothing can ever change. So if we have something like this is a similar situation to before. If we call calculate something with some arguments, and then we have this get data, we don't have to worry about, like in my example, right? When we called get data, all kinds of things could happen, right? Global variables can be reassigned, even console.log could be reassigned. But if we live in a world where nothing can change and everything is immutable, then you don't have to worry about that. Another nice benefit of this is if you call the same function with the same arguments, you'll get the same value back for sure. This isn't necessarily true in JavaScript. So like you could, for example, have a function that reads from a global variable, something like that, and that global variable can change. So each time you call the function, you could get different things back. In functional programming, whenever you call a function, you can be sure that you're going to get the same value given you pass in the same arguments. And this is actually a really powerful concept. Something else that you have in functional programming is side effects. So a side effect is basically anything that changes the state of the world. So writing to a file, that would be a side effect. Reading an input, that would be a side effect. Printing something out is a side effect. Any kind of I/O operation, input, output, if you're displaying something, anything like that is going to be a side effect. And we don't allow these in functional programming because they can be like another kind of state, right? If you're reading from a file, well, that file could change. Or if you write to a file, someone else might be reading the file, that file could change. So for that reason, we also outlaw that in functional programming. So here is an example of a function that would be not allowed in functional programming, right? Add and print. We add two numbers together, then we print. Well, okay, printing is not allowed. That's a side effect, so not allowed in functional programming. So if you kind of combine the last two things we talked about, no side effects and immutability, you get all your functions become what's called a pure function. So there's this big word, referentially transparent, right? What does that mean? Basically, it just means that all variables are immutable and your function is pure. It returns the same thing every time. So if you have a pure function, here's some things you can check to like make sure you're writing functional pure functions. Don't read from global variables unless it's like a constant. So if you want to have like pi or something or like a define in C, that's fine because that will never change. It'll always be the same. It's like a find and replace. It's not really the same. But don't read from any global variable that could change. Don't modify your arguments. So if someone passes you in a number or anything like that, if you're passed in an array, don't append items to it, right? That would be modifying your arguments. And you should be returning a value. And the reason this is the case, if you have a function that doesn't return a value and it can't do any side effects or change anything, then your function doesn't actually do anything. So if you have a function that you think is useful, but it doesn't return a value, then it can't be a pure function. Because the only useful thing a pure function can do is take in information and return you different information, since it can't have any side effects. And the last thing you can do, if you can check this, you should be pretty sure it's a pure function. If you can replace it with like a lookup table, so an example would be like the sine function from math, right? Does anyone know what sine of pi over 6 is? Anyone in like trig or calc? No? Okay, 1/2. Yes, awesome. No matter what. Now, what if it's Tuesday? Or what if I change the value of some other variable? Or what if I write to a file? What's sine of pi over 6? Still 1/2, right? No matter what, sine of pi over 6 will always be 1/2. We can replace it with a table. And in fact, before we had calculators in like wide circulation, a lot of times students did have a table for looking up sine values or log values. Maybe cooler on Friday. Yeah. No matter what, right, your sine is going to be the same thing. You could replace it with a lookup table because it's guaranteed that sine of pi over 6 will always be 1/2. That's how you know it's a pure function. Okay, so now we're going to go through some functions and see what do people think. Is this a pure function? So this is a get random function. We take in a minimum value and a maximum value. It's a range. And all this does basically is it computes a random value. Okay, so we have some people saying no, some people saying yes. Okay, well, the answer is no. It can, as some people pointed out, it can return different values even if you give it the same arguments, right? So you can't, this isn't a, if you call get, you think about this, you can't replace it with a lookup table, right? If you call this with 1 and 5 and you get 3 the first time and you call it again with 1 and 5, you're not guaranteed to get 3 again. You could get a different number. For that reason, it's not a pure function. Okay, what about this? We already saw this example earlier, so hopefully people remember. Pure function, yes or no? No. Okay, yeah, this is not a pure function. Why? It has a side effect. It prints out a value. Another good warning sign is, look, we don't return anything from this. We just print something out and we don't return back a value. If you're not returning a value, that's a good sign that you're relying on side effects, like modifying variables or printing something out. That's the actual work of the function, which means it's not pure. Okay, what about this? Append twice. So we take an array, which is a list, and then we take in an item, and then we have that push.push, which is like appending to the array. So we take that array and we append this item, then we append this item again, and then we give back the array. Okay, so no. But I thought, okay, but you might be thinking, he's returning the array, right? We return a value, right? It should be fine. Well, no, because yes, it modified state. So we have this array, and if you passed in this array variable, if whoever called this function still has access to that array variable, it will be changed. So this is an example of modifying one of your arguments. So pure functions never modify their arguments. Consent. Yes, basically in functional programming, you don't modify arguments without the consent of whoever called. And what that means is basically you never modify your arguments. Instead, if you want to do something like this, return a new array that has those items appended to it and leave the caller's array the same way it was before. Okay, what about this function? Add and divide. So we take three numbers, we do some math, and then we return the value. Pure function? Yes. Okay, good. This is a pure function because, look, it doesn't modify its arguments, no side effects, doesn't print or read from the user or anything like that. And we could make this a lookup table, right? If we had a huge table with all the possible values of A, B, and C, for a given A, B, and C, you'll always get the same result for this. So pure function. Good. What about this? This one's a little bit harder. So what this basically does, it's a make list function. You pass in a number, and then it will make you a list that is that length that has just 1 to n. So if you pass in 3, it gives you a list that has 1, 2, and 3. If you pass in 4, it gives you 1, 2, 3, 4 in a list. Is this a pure function? Any guesses? Hopefully. Yes. Okay, so we have some people saying yes, it is a pure function. So you might be thinking, okay, what about the array.push? Haven't we already established that mutates things? And yes, technically it does. So that is a mutation, right? We're modifying our array. But unlike before, that array isn't an argument. So nobody else knows. We're kind of bending the rules. We are doing a mutation, but nobody else could possibly know that we did it. So for all intents and purposes, this is okay, and this is a pure function. Generally what that means is if you're trying to write pure functions, any variables that you create inside of the body of your function, you can mutate because no one else should have access to them. Anything that's given to you, so if you have anything passed in or if you're reading any variables globally, those things, if you can't change because other people could have access to them. Okay, so you may have been, especially early, you may have been wondering, if we can't change anything at all, if we can't print anything, we can't do any file I/O or display anything to the user or take input, aren't we just limited to math? Like how do we actually do anything? And this is definitely a valid concern. There actually are, like in a programming language like Haskell. Haskell is like the poster boy programming language for functional programming. And it actually does have requirements like this. You're not allowed to modify any variable. Every time you set a variable, you can't change it at all. And you can't, there are ways that you can print things out, but they are more complicated. Like they use a lot of abstractions to kind of cheat and get around the system, but it is difficult to actually get work done. So this is a valid concern. Luckily, these are just ideals. So when we're doing functional programming, at least I'm a big advocate of, I'm not saying you shouldn't go, walk away from this talk and be like, functional programming, Rob said never change anything. So I'm never going to modify another variable ever again. It's not something, it's an ideal. You strive to do this, but at some point, you're going to need to change something. You're going to have to display the results to your user somehow. Otherwise, your program is just pointless. So when we are programming with functional programming, our goal is just to minimize this. So it's okay if we change things, but we want to try to keep it limited, not change too many things. And it's okay to do side effects, but we want to control them and make sure that we keep the side effects as minimal as possible. Not having functions and classes and things all over the code base changing the same variables, because then it'll quickly get very confusing. So we just want to try to keep it manageable. That's our goal here. So functions. If you've been kind of confused about, okay, what is a function this whole time? Here's what a function definition looks like in JavaScript. So you write function, then you type the name of the function, so sum, and then you have these parentheses. Inside those parentheses, you have a comma-separated list of arguments. Those are your inputs. They're called arguments, parameters. Those are the main things people call them, but those are the inputs. That's what whoever uses the function will provide you with those. Then you have the return value. So we have return a plus b. The return value is what you give back to the caller. So when you use a function, it's called calling a function. So if you're in Intro to C, for example, the printf function is a function. It's not a pure function, right? Because it prints something out and it doesn't really return a value. So not a pure function, but that is a function. It takes in arguments, what to print, and then it does side effects by printing things out. But this sum function takes in arguments and then returns back their sum. So that's all there is to a function. Fairly simple idea. The sad part about this is a lot of typing. If you think about adding two numbers is like a pretty fundamental, simple idea. But we have to type this function, and we got to do these braces and do this return. It's a lot of typing, and it's in functional programming, we basically have two tools, functions and types. So functions are like at least half of everything we do. So it should be easy to use them. So that's why we use lambdas. So there's our function definition from the last slide. You can kind of make it, we can do better by removing the name. So we don't really need to call this sum. It's fairly obvious what it does. And we can kind of move it all together on one line. That makes it, okay, a little bit cleaner. But the best thing you can do is to use this arrow function. So this, look how concisely we can express the same idea. We take in an A, we take in a B, and then arrow, we give back A plus B. We don't have to do return. We don't have to write function. We don't have to give it a name. We can just directly express a function. So this is called a function literal or a lambda. It's the same thing. Basically, just like how you can have a number literal like 5 or a string literal like KnightHacks, right? Or even a character literal like C. You can have a function literal, and this is what it looks like. It just is directly, it doesn't have a name, it expresses a relationship from inputs to outputs. And in JavaScript, you also have the ability, if you only have one argument, you can even drop those parentheses. So if we just want to have express the idea of adding two, we can just say, okay, we take in a number, A, then we return A plus 2. And this is a really great concise notation that was introduced in JavaScript several years ago now that is really useful. And that kind of led to the birth of functional programming in JavaScript. Okay, questions. Do you only program in functional programming at your job? Well, okay, one, I actually don't have a programming job. I'm a student here at UCF, so not sure what you mean by that. But in my personal program, I use functional programming in my personal projects a lot. And then printf returns the number of characters it printed. Okay, so it does return a value. It still isn't pure because it has side effects. But thank you for that correction. Okay, so with these function literals, when you have a language with function literals, you have what's called first class functions. So just like you can do const pi equals 3.14, you can say const sum equals this function literal. You see how the two declarations have very similar layout? Is the lambda something specific with JavaScript to say whether it was? No, many languages have lambdas. Some languages have better or worse support for them. So and that's one of the features that has been added. If you 10 years ago, Java didn't have lambdas, but now you do have a lambda expression that works mostly like a lambda. Most modern languages will have lambdas, but JavaScript is one of the biggest ones that has had good lambdas from the beginning. Yes, it actually does come from a branch of math called lambda calculus. If you actually, so kind of random digression, but if you've heard of like a Turing machine before, right? A Turing machine is basically the idea that anything that you can compute, you can calculate by a machine that has an infinitely long tape that you can write zeros and ones to. Well, there's an equivalent construct called the lambda calculus, and anything that's computable, you can compute just using functions without changing anything at all, actually. So, and that's kind of where functional programming comes from. So, okay, this is very important though, this slide. Make sure you understand, you'll often see this bottom syntax used. A lot of people write all of their functions this way, especially functional programmers will prefer this style over the function. So get used to seeing this sort of arrow style declaration. But what I really want you to notice is you can use a function just like any other value, right? We can have const pi equals 3.14, or we can have, const name of this hackathon equals KnightHacks, and we can have const sum equals this function literal. That's the important takeaway from this slide. Because of that, when you have lambdas or first-class functions, you can pass a function as an argument into another function. So just like we can do console.log and then KnightHacks to print out KnightHacks, right? We give console.log that KnightHacks so it will print it. You can pass a function in as an argument to another function. So let's look at what that might look like. So look at this kind of second block down here. We have this do twice function, which is it's a higher order function. And what that means is it takes in a function as one of its arguments. So what it does is we call do twice with a function. That's fn. What it does is it returns us a new function, right? Because this is a function literal. Don't get confused by the series of arrows, right? You can kind of think of this as all one block. This whole section here, that's all one block. So we take in a function and we return this. Well, what is this? This is a function. So we return back a function that will take a value, a, and then it will call that function we originally got with the value, and then we'll call whatever the result of that is, it will use that same function again, right? So it applies that function twice. Does that make sense to people? If you're confused, please put a message in the chat because all of the slides after this depend on this kind of idea. So if we wanted, here's how we could write a times 3 function, right? We take in a, then we return a times 3. So if we wanted to write a times 9 function, we could just do something like this. Take in a and return a times 9. But we could also do it like this. We take our times 3 function and we use do twice. And so now what will the result of this call be? We take our do twice, we give it times 3. So times 3 is this function right here. And now it gives us back this function. So this other function is waiting for an a, and when it gets that a, it will call times 3 on it, and then it will call times 3 on it again. And so in this case, when we name this times 9, because that's what it will do. So it'll take in the 2, right? So that 2 is really going to this a here. And then we're going to call, okay, our function, which is times 3. So 3 times 2 is 9. And then times this outer function, times 3. And 3 times, is it the wrong? This is the wrong value? Oh, shoot, my slide's wrong. Okay, it should be, yeah, it should be 27. Okay, sorry about that. It should be 27. It should do, oh, wait a minute, times 3. No, it'd be 6. Sorry. I'm doing horrible math here. Math is not my specialty. So we take in this 2. We're going to multiply by 3 and get 6, and multiply by 3 again and get 18. I know that was kind of confusing. Does that make sense to everyone? All right, I'm going to take the relative silence as a yes. Okay, so you can also do this anonymously. So you don't have to, that times 3, remember that? We don't have to actually explicitly give it a name, right? Because all we do is pass it in. So instead, we can say times 9 is equal to do twice, and we just straight up pass in our times 3 function without ever giving it a name. We achieve the same sort of thing. So, okay, this is kind of interesting, but honestly, you would never write a times 9 function like this. This is stupid. You would just do it the a arrow a times 9. What can we do that is useful with first-class functions? And if there's any slides in this entire presentation that like you pay attention to, like if you've been at this workshop and just sleeping away, these next like 6 slides or so are the ones you should pay attention to, because this is stuff you can actually use in your everyday programming. Like map, I use almost every day when I write something. It's so useful. So you often have this sort of problem. You want to iterate over a list and do something to each element. So say we have this list that's 0, 1, 2, 3, 4, and we want to add 1 to each item for whatever reason. You could do this with a for loop. So if you're familiar with any C-like language, you've seen this sort of construct. We use let instead of like a type because JavaScript has pretty weak typing. But it's mostly the same, right? So we let our I equals 0. We iterate through each element, adding 1 each time. And we're going to set the element at I to that element plus 1. So we're just going to bump each element by 1. We can log it. Boom. But if you look at this whole for loop, like all of this stuff really has nothing to do with the idea. All we want to do is add 1 to each element. Surely there is a better way to do this. There is. We have map. So what map does is it maps a function over each element of an array. So we have our same stuff array, 0, 1, 2, 3, 4. And what we do is we take our stuff array and we do stuff.map, and then map is a higher order function. Map takes in a function, the thing that it's going to apply to each element. So we give it our plus 1 function, right? So we say basically take each element and then change it to be that element plus 1. And what the result of this whole thing doesn't mutate stuff. So it's not exactly the same as the other. It doesn't change stuff. What it does is it gives us a new array with this edit made. So stuff will still be exactly the same. This is how we can actually get work done with everything being immutable. Instead of stuff is going to still be the same, but the result of this map is going to return us a new array that is 1, 2, 3, 4, 5. This is so useful. Addition is like a simple example, but it's very often you want to do something like take a list of, if you're writing a program, take a list of IDs and get back a list of users. Well, instead of iterating over the list, just map, take in our ID, and then do all of your logic that gets the user, and then return the user. You can get an array of your users. This pattern comes up so often. And if you look, think about it, it's much better than this. At first, it might be kind of confusing, but once you get used to it, it is a much more expressive and simple form. You don't need all of this let and this I. It doesn't really even have anything to do with what's going on, right? All you want to do is add 1. This is a much more expressive way to do it. Some languages, you have this sort of middle ground you can use, like a for each loop, where you do for const I of data. And so you can get each element out. So you can do a similar sort of thing, basically. So we have our data, 1, 2, 3, 4, 5. We want to make a list of everything incremented, so we can take out each element. Python is especially infamous for this. It has the for in, which, by the way, does not work in JavaScript. There is for in JavaScript, but it does something different. I have some optional slides on that we can go over later if people are interested in that. But this is something sort of similar, but still not as good as map. Okay, here's another higher order function similar to map. Yes, okay, so a list comprehension is an idea from functional programming. It's basically just a souped up version of map. That's all it is. Because look, it's all the same things. Instead of x arrow x plus 1, you have x plus 1 for x. And then instead of having the list dot, you just have in list. And then you wrap it all in the list. It's the same idea. And it's just better. It's more expressive than doing a for loop. Using this, I've eliminated like most for loops from my code. I almost never write for loops anymore. This especially is helpful. So if you want to do side effects, right? Obviously, we can't always live in our pure functional world and never print out anything. Say we want to print out each element. Instead of using a for loop, you can use for each. So the only difference between for each and map is that map will give you a new array back. But if you don't want a new array back, if your only goal is to do a side effect like printing something out or modifying some variable, then just use for each. It does the same thing, but it's more efficient. So in this instance, we can, for each element in our data, we can take our x and we can constant.log that x. Okay, filter. This is another very helpful one. Less used than map. Map is by far the most helpful, but filter is still very useful. Sometimes you want to take a list and take out some of the elements. You want to shrink it or filter it down. Here's how you might do that in an imperative style. So you have your list of all your scores, like on a test or something. Then you have all your passing. You have another list where you store the scores that are passing. So we're going to go through. So for each score of our, this should be scores. I was editing this earlier. So this should be scores. Ignore that. But for each score in our scores, if that score is greater than or equal to 60, then we're going to append it to our passing list. So basically what we're saying is anyone who is bigger than 60, we're going to iterate through each element here. Anyone that's bigger than 60, we're going to append to our passing list. And then we can print out our passing list. Great. Okay. But again, we can do better than this. Filter lets you do the same idea, but it's just more concise. So we have our same list of scores, and it works a lot like map. You do scores.filter, and then you pass in a function that returns either true or false. If it returns true, then the new list will contain the element. If it returns false, then the new list will not have the element. So in this case, we take in our score and we return if the score is greater than or equal to 60, right? Because this expression will either evaluate to true or false. And just like that, you're able, the other thing about this is it doesn't mutate this list, right? We still have our original scores if we need it, and we can get back our list of all the scores greater than 60. Okay, reduce. So reduce is a little more complicated, but it's basically a way to collapse a list down to one element. You can do a lot of things with it once you get more experienced, but one of the simplest examples is just to sum a list. So you could iterate and like try to add all the elements, but you can express it very simply with this. Basically what you do for a reduce, so just like map or filter, you do dot reduce. You pass in a function that takes two arguments, an accumulator argument and then the current element. So the accumulator is just what's been building up, right? It runs this sequentially, it builds up these values. And then the current is a single element. So, and then in this case, we want to add all of these together, right? So we take our accumulator and we add the current element. And then our first accumulator, the second argument is optional, but if you do provide it, then that will be your initial accumulator. So we start at 0, so this will run through. And what this will do is 0 will be the accumulator, then current will be 5, and it will return 5. Then that 5 will become the new accumulator, and then it will pass in 3. And 5 and 3, that will give you 8. And eventually it will add them all together. And this might look kind of strange if you're new to functional programming, but I promise you, if you start using this in your throughout in your daily programs or whatever things that you use, it will in time make a lot more sense and be a lot cleaner than doing it in the imperative way. Okay, so at this point, we're going to go through some more examples to kind of help solidify functional programming and how you would use it. So write pure functions, right? So don't do things like this. Don't notice in our print total function here, we don't take in any arguments. We read from a global variable, right? Prices. And then look, we also do a side effect. We log something out. This is bad. What would be good is to write it like this. So we take our prices, and instead of having the function print out the total, instead we should make it pure. So take that console.log and move it outside the function. So all our function does is takes in the array. Instead of reading it from a global variable, it takes in any array, not necessarily just this one, and it will do the reduce to add all the elements together and return the value. And then the caller, or the outer scope here, is able to print that out. So you use a pure function. And the other thing is this is much more reusable, right? This works with any list. This will find the total of any list. This specific thing only works with this list, and it doesn't even give you back the value of the total. It will only print it. What if you want to do something else? Does the reduce only work with numeric values? No, but that's the simplest example I can provide, especially for people who are starting. You can use it with strings to like concatenate strings together. You can do crazy, crazy things with reduce. I just unfortunately don't have time to get into that today. Okay, avoid global state. So this is a JavaScript object. If you're not super familiar with it, don't worry about it. Basically what you have you have a player, and the player has a HP property. If you want to get access to that, you can do player.hp. So we have this function here that does update HP, takes in a value for the new HP, and then it sets that player HP to that. But this is bad because it's using a global variable, right? It's using player, it's not passed in. A good way to do this, at least, or the functional way, that's something else I want to bring up. The functional way to do something isn't always the best way. So just because you see something under bad on my slides doesn't necessarily mean it's something you should never do. And just because it's good doesn't mean it's always the way you should prefer. But in a functional style, this is what you should prefer. If you're doing the bottom, you're doing functional programming. If you're doing the top, you're not. There are a lot of advantages to functional programming, but there are disadvantages too. There are reasons to do things in different ways. So just keep that in mind. Instead, what you might do in functional programming is you make a copy. So we have our update HP. We take in not only the new HP, but the player, right? Instead of accessing the global, this is a very common pattern in functional programming. Instead of accessing a global variable, pass it in as an argument. And then instead of editing that variable, copy it. So this ... player will copy all the properties from player. And then we override the HP right here. So the important idea here is we're not using global variables and we're copying our values rather than mutating them. Okay, use dumb data. So if you've taken an object-oriented programming class, you've probably seen something like this, where you have a class that has some different values, and then you have some methods that do some different things with those values. So we might have a player who can take some damage, right? Then we'll subtract that damage from his hit points. And we might also be able to print out, okay, what is his name and how much hit points does he have? So you can see how you might use this. You const player equals new player and deal 10 damage and then print it out. Okay, this works, right? But in functional programming, this is bad. You want to use dumb data instead of objects because look, ultimately what this is mutation. It's difficult to say what things can change inside this player, which can complicate our code. We never want to change things in functional programming. So instead, you might write it like this. Instead of having a class, just make a normal object with name and the HP that you want. And instead of having methods, have free functions. So have a function that will take in a player and how much damage, and will give you back a new player with that much damage taken off. Instead of having a function of the player that will print something out, have a function that converts the player, takes the player and gives you the string you want, and then log it out on the top level. Notice how we're taking, I know I've been doing this a lot, but you want to take your console.logs, your prints, your side effects, and move them out of your functions. Don't make a function that calculates a value and then prints it. Calculate the value in the function and then return it, and let whoever called you print it out. That's what you do in functional programming. This is definitely going to be controversial for people who are familiar with object-oriented programming. So if you're in object-oriented programming right now, kind of ignore this slide because this is like blasphemy in object-oriented programming. So this is the object-oriented way to do it, which is bad. Object-oriented programmers would say this is good, but in functional programming, it's bad. So instead of having here, you can see you have this abstract class, which would be like a shape. And you can have different shapes. You can have a square, you can have a circle, and each one calculates its area in its own way. And the reason you would want to do this is, look, we can make a new circle with radius of 1, and we can get the area. And our square works the same way. We can make our square with side length of 1 and get the area. We don't have to do anything different. They both work the same way. That's kind of nice. In functional programming, though, we don't want to have methods on our data structures. So instead, this kind of goes along with the use dumb data structures. Just have the data structure. So our square the square no longer knows how to calculate its own area. It just knows how to store its length, side length. And circle doesn't know how to calculate its area. It only stores its radius. And now we can write one function that works on both. So our function calculate area will take in a shape and we'll check if the shape is a circle, return 3.14 times, that's the area formula for a circle. And else, if it's a instance of square, so if our shape is a square, use this method. And then it's always smart to do something like this. Throw an error if somehow a shape got in that isn't one of those. Like maybe you added a triangle, but you forgot to update this function. This one especially I want to stress. Don't don't do this in object-oriented programming, because this is specifically like anti-object-oriented programming. This is one huge break that functional programming does. And for certain problems, it makes more sense to do it this way. This way is usually better if you intend to add more shapes. So if we want to add more shapes, this is better because we can edit, each shape can take care of its own area. But if we want to add more functions, like say we want to have another function that does something for each shape, like maybe draws the shape with that area. If we do it this way, we would have to go to every single file, because usually you would store this in a different file. So you'd have to go to the square file and add a function to draw a square. Then go to the file and add a function to draw the circle. Versus this way, you can just add one function, handle everything in one place. It makes your code editing easier. So depending on the problem, it can be smarter to do it the functional way or the object-oriented way. But in functional programming, doing instance of, or doing like, this is what we call a pattern match. You have a pattern matching feature and more languages more tailored for functional programming. That's what you would want to prefer. And then, okay, lastly, if there's one thing you take away from this talk, use map filter reduce. This example is especially egregious. If you look, my code doesn't even entirely fit on this slide. It has like it's made a bar to scroll it for me. But basically here, we're taking a list of scores like we did before, and the teacher wants to curve it. So they're going to add 20 to each score. So we'd have to do a loop in imperative programming. And then they want to find who's passing. So we'd have to do another loop through and check which scores are bigger than 60 and put those in the passing list. Then they want the class average. So we'd have to, again, do another loop. And I even made this one line to try to make it all fit, but it still doesn't fit. So we do a loop and add up all the values. And then we do a final division and we'd be good. In functional programming, look how much better this is. So look at this. We took this. Now we have this. It's much less code, right? And also it reads more simply. So we have our scores, our curved scores. We're just going to map x to x plus 20. We're going to add 20 each one, right? Because that's what we want to do. Why do we need to have all of this overhead? We don't need all of this stuff here. This is all just code that it makes it more confusing, harder to understand. This is very simple. You can see, okay, we're going to take each score and add 20. Then here, same thing with the filter. Instead of iterating over and doing this check, it's just a lot of lines of code to do not that much work. We can just do a simple filter to get all the people who are passing. Then average, we can use reduce to add all the numbers, and then divide. It's just a much simpler policy overall. So that's the end of my slides. Looks like we have about 2 to 3 minutes here for questions. Does anyone have questions? And yes, I see Henry has posted immutables.github.io. Yes, so there are libraries you can use. I know in JavaScript, there are a lot of functional programming libraries. There's immutable.js is a great library for immutable data structures. So if you want to have arrays that actually won't let you change them, or objects that won't let, or a map that won't let you change it, like a hash map that can't be changed, immutable.js is where you want to go. Those are definitely very useful. Do I have any questions? For the passing const, what do you mean by that? Do you use any functional languages like Haskell or Clojure? So I've been trying to teach myself Haskell to some extent. I'm not like super confident in it. I'm not sure I could like write an application using Haskell, but I understand a lot of the concepts in that. When I understand it more, I'm hoping to give like a more in-depth talk, because I think this is kind of like, if you think about the 80-20 rule, right? Like 20% of the knowledge will give you 80% of the results. So this is the 20% of functional programming, just the tip of the iceberg, but it will get you a lot of mileage, especially map, filter, and reduce. If you learn those, you can simplify a lot of code, and it's very easy to do. So I haven't used a whole lot of functional programming languages, but I have looked into them. Will const passing know to use the new array from map? Do you have to define it when you run it or something? Will const passing know to use the new array from map? Okay, so I'm a little, oh, you mean like on this slide. Okay, this passing. So const, this is a variable declaration. So we're saying make a new variable that's constant, called passing. And filter is just a function. So filter returns filter's a function that takes in this function, uses the array it was called on, and returns a new array. Does that make more sense? I'm not too certain I understand your question. If someone else, if I'm missing something obvious, please someone post in the chat. Basically, when you call .map or you call .filter or you call .reduce, this returns, it's a function call like a scanf, for example. Scanf's not a pure function, but this is a pure function that returns you back a value. And that's what we're storing into average, passing, and curved. I hope that makes more sense. Does that make more sense? If it doesn't, just say no, and I'll try to see if I can explain it in a different way. No, okay. Will it be acting on the new array generated? So passing, okay, maybe this will make sense. Scores is this array, right? We can agree on that, easy peasy. These numbers, this array is what is inside scores. Curved contains 50, 65, 80, 75, 40, 102. Does that make sense? Passing will contain, passing is using this curved array. So it'll check, is 50 greater than 60? No. So that one's struck. Is 65 greater than 60? Yes, so there'll be a 65. Okay, you didn't see that? Yes, so this one I use curved, and you see this a lot in functional programming. You have a bunch of these dot functions here, and you just keep storing everything in a const and then using it, and then storing that in here and then using it. And you see this kind of pattern a lot. You don't do like loops, and you don't have let, and even a lot of ifs, like you just don't have, or while loops, you don't have that. You calculate something, store it in a variable. Use that new value to calculate something, store it in a const, and then eventually you return. Yes, you can chain. I was just in this example for people who are new to functional programming, I try not to chain too many things, because if you start chaining things, so you can chain this, because if you really think about this, in this example, I use curved twice, so we wouldn't really be able to do that. Not easily, at least. But you could just make passing equal scores.map this .filter, and just put the .filter right here at the end of this line, and make that passing. Because remember, this returns that value. You don't have to give that value a name. Just like you can use anonymous functions, you can have this will give you back an array. You can immediately call .map, .filter, or .reduce on that. And if you have like multiple, you see this with filter a lot, or even map, but filter is a great example. Like maybe you have a list of users and you want to get all the users who are in the state of Florida. So you do a .filter and you check if they're in Florida. And then you want all of the users who are over a certain age or have a premium account or whatever. So you do another filter to check for that. And you can either chain the filters or you can do an and inside the condition. There's different ways you can do it, but you can chain these and have a big line of dots. Especially if you use promises. That's another thing. Promise chaining is huge. Promises are from functional programming. Async await is from functional programming. Try catch is from functional programming. It's all those things have been adapted into like mainstream languages, and they're all stolen from functional programming. All right, so I'm a couple minutes over already. Are there any last questions or anything anyone else wants clarified? Nope. Okay, I'm going to go ahead and shut down this talk then. Thank you for coming to my presentation. I do appreciate it. And good luck at KnightHacks.